Buenos dias, team. Today I wanted to go over 4.6, or how to graph reciprocal trig functions. So in class I gave you the handy dandy graph it yourself activity thingy, which was this beautiful worksheet. So we had our table of values for sine, cosine, and tangent that we used to graph sine, cosine, and tangent, and then use those same graphs to graph our reciprocal functions. So let's look at what those are supposed to look like. So one of the things that I recommend when graphing reciprocal functions is to start with the graph of their parent function, I guess you could call it. So like if we're going to graph secant, for example, secant is the reciprocal of cosine. So secant is the reciprocal of cosine. I forgot my stylus, so please excuse the ugly writing. So secant is the reciprocal of cosine. So let's start by looking at what does cosine look like. Well, cosine starts at 1, and it has that period of 2 pi. So it's going to go down to -1, back up to there, and then the other way. It goes like this, and then it kind of rounds off. We get some beautiful oscillations going on in here. Yes, so nice, lovely, lovely, lovely. So this is our cosine graph. So when we want to graph the reciprocal functions, we want to start by looking at where are those x-intercepts of the parent function. So when the parent function is equal to 0, the reciprocal function, 1 over 0, that's where we're going to get vertical asymptotes. So by graphing the parent function first, you can then go back in and be like, oh, well, I'm going to get some vertical asymptotes everywhere that that parent function crosses the x-axis. So I'm just going to hop in here. Actually, I'm just going to draw straight lines. That's faster. So everywhere that we cross the x-axis, that's where we get some vertical asymptotes. So then from there, our peaks, or our crests and our troughs, so the high and low points of our parent function, they're going to share that point. So we're going to share these points. Boop, boop, boop. We're going to share these points. And then we can look at, okay, well, if my cosine is positive, that means my secant is also going to be positive. So the shape of this kind of swirls out and makes this cute little like U shape that approaches these vertical asymptotes. So if we're above the x-axis, if our cosine is positive, our secant is positive. And if we're below the axis, our secant is negative. So our secant graph looks a little bit like that. And if we go in and erase our cosine, and if we erase our vertical asymptotes that we used kind of as a stencil, that's what secant looks like. So it's got these fun little like back and forth U-looking Johns going on. All right, so we can then do the same thing for our cosecant. So if we look at our cosecant, let me erase all my little dudes. So let's look at the cosecant. So cosecant is the reciprocal function of sine this time. So we got a reciprocal function of sine. So let's start by graphing sine. So sine starts at 0, and it's got that period of 2 pi. So it starts at 0, goes up, and oscillates. One full swoopy this way, swoop, down, swoop, up, and then it comes back this way. So down, up. Beautiful. So there's our sine. So we want to do the same thing. We want to start by asking ourselves, okay, where does sine cross the x-axis? Where are those vertical asymptotes of cosecant going to be? So I have one here, I have one here, and I have one here. And also over here. Can't forget that one. So once we have our vertical asymptotes, we go and look at, all right, what does sine look like? Well, sine has a minimum here. So that means my cosecant is going to go swoop like this. Swoop. There's a maximum here, so it's going to go swoop. Swoop. And our minimum here. Swoop. And swoop. Like so. So again, if we plot our parent function, our reciprocal function, the asymptotes are where a parent function crosses 0. They share their max and min points, and if sine is positive, it opens up. And if it's negative, it opens down. So secant and cosecant, just like sine and cosine, look very similar, just shifted by 90 degrees. So we get that up, down, periodicity again. All right, so our last one, we want to look at tangent and cotangent. So again, let's start by graphing our tangent, because cotangent is 1 over tan. Now tangent is the weird one of the bunch. So tangent starts at 0, and it only has a period of pi, and it's got vertical asymptotes. So I'm going to go ahead and put in my vertical asymptotes for tangent. Every pi, close enough. And I know that at root 2, or at pi over 4, tangent is 1 and -1 respectively. So we get this nice little symmetry going on. So I'm going to go ahead and plop in the points that I know tangent exists at. So then we kind of swoop up towards our asymptotes on the right side. So we swoop up towards our asymptotes on the right, and we swoop down on the left. And these are very approximate. You can get better graphs by including all of the points that we know. But this is just giving us the idea of the general shape. Ugh, not like that. And then we come down, we're like swoop, swoop, blah, blah. All right, cool. So same deal, since cotangent is the reciprocal, everywhere that the tangent is 0, the cotangent is going to have its vertical asymptotes. So I'm going to go in and I'm going to be like, all right, tangent is 0 here. So let's draw our little vertical asymptote. Tangent is 0 here. So let's draw our vertical asymptote. Boop. Got a vertical asymptote here. Boop. And a vertical asymptote here. Boop. Now with cotangent, we kind of get the opposite thing. So where tangent crosses 0, there's a vertical asymptote. So the reverse is also true. Where tangent has a vertical asymptote, cotangent is going to have a 0. So cotangent has a 0 where tangent has a vertical asymptote. And then they also share that pi over 4, because at pi over 4, tangent is 1, so the reciprocal is also 1. So they also share these 2 points, which is why I like to use them to graph. So we know that they also share these points. So then our cotangent, it basically looks identical to tangent, just mirrored and shifted. So then we get that nice. And so when you plot them on top of each other, they make this really cool pattern that I'm a big fan of personally. I think it looks neat. Swoop. And swoop. So everywhere that tangent has a 0, cotangent has an asymptote. And everywhere that tangent has an asymptote, cotangent has a 0. and then they share those tangent equals 1 spots at our multiples of pi over 4. So we can erase our original tangent to get a feel for what cotangent looks by itself. Doop, doop, ta-da! Chef's kiss. Okay, so that's how we graph our basic ones. So what happens if we want to graph harder things? So let's say we want to graph the secant of x plus pi parentheses plus 2. So we want to do the same thing that we would with our periodic functions. So we want to start with, okay, secant. Secant is the reciprocal function of cosine. So let's start by seeing what cosine of x plus pi plus 2 looks like. So again, I forgot my stylus. I'm really sorry. I'm doing my best. X plus pi plus 2. So let's start by graphing the cosine of x plus pi plus 2. So if we look at that, there's no number in front, so our amplitude is 1. We have a phase shift of pi, a vertical shift of 2, and our period is still 2 pi because we don't have any numbers in front of our x. So because we have that vertical shift of 2, I'm just going to go ahead and put a line at 2 to help us figure out what we're oscillating around. Okay, so normally cosine starts at 1. So if we're shifted by 2, we'd start at 3. So normally cosine starts at 1, comes down, boop, boop, boop. But since we're shifted by pi, and it's plus pi, so that means a left shift by pi, I'm going to take that 1 and I'm going to go left by pi. So I'm going to come over here to negative pi. And then I'm going to follow the same pattern that I usually would. Boop, boop. So every 3 boxes, I go up, down, boop. The nice thing about having the graphs have boxes be multiples of pi over 6 is it makes it a lot easier to graph periodic functions. Big fan. And then we go swoop. It's actually not a bad cosine. All right. Okay, so again, we've got that shift of pi, and then we're shifted up by 2. So it actually, if we look at it, it really just flips our cosine 180 degrees. So it's actually a reflection across the x-axis if we shift by pi, which makes sense, right? Like cosine of 0 is 1, cosine of 180 or pi is negative 1. So we're just basically flopping it over and then shifting it up by 2. So now to get our secant, so we plotted the parent function, so now let's get our secant. So let's look at, okay, where do I cross my axis? Oh, well, I cross here. So that means I'm going to have a vertical asymptote here. I'm going to have a vertical asymptote here. And I'm going to have a vertical asymptote here. So where we cross our axis, if we're shifted up, corresponds to where would we cross the x-axis? Where would those zeros be if we were down below? Okay, so now we do the same thing. We say, okay, well, where's my peaks? So here's my peak. I'm going to come shoop up like that. And here's my trough. So I'm going to go shoop down like that. Shoop. Here's my peak. So even though it's off the graph, it's going to kind of come swoop like this, swoop. And I'm going to go swoop like that. So you always want to start by graphing what does my parent function look like that has all of the same translations applied. Let me graph that first. And then I'm going to use that to figure out, okay, where's my asymptotes? And then where's my peaks and my troughs, my crests and my troughs. And then make your little U-doodads in order to make it beautiful. All right, we can also do some fun things with our cofunctions. So in this case, we want to use tangent and cotangent in order to figure out what these graphs look like. So if we look at this one on the left, we're like, this looks awfully suspiciously familiar to what we've already plotted before. So notice how we have a vertical asymptote at 0. We're going decreasing, so we're like starting high and getting low, cross at pi over 2. So since we're decreasing, that looks like a cotangent already. We got that asymptote at 0, we're decreasing, and we cross pi over 2. So this graph on the left is actually already cotangent. So this is a graph of cotangent. Our period is still pi. We didn't shift it anywhere. We didn't shift it up or down or left and right. So this is just the cotangent of x. If we look at this graph on the right, it looks basically the same, but we shifted it pi over 2 to the left. Or right, honestly. You can look at it either way. So we shifted it by pi over 2. So this one is going to be the cotangent. And I'm going to say that we shifted it to the left. So this is going to be the cotangent of x plus pi over 2. So it looks exactly the same as the graph on the left, except we just shifted it, gave it a little phase shift. Okay, so now we want to write these in terms of tangent. So the first thing that we need to do, well, tangent, I gotta flip it, right? Because tangent increases. So like, if I were to superimpose a tangent onto here, this would kind of look like this. Shoop, shoop, shoop. Right? So what I'm looking for is I'm looking for a negative tangent. So if I take a negative tangent, that's going to give it that decreasing shape. So I know I definitely want a negative tangent in order to get it from increasing to decreasing. However, tangent crosses at 0. So tangent crosses at 0 normally. So normally tangent looks like this. Shoop, yeah, shoop. Normally tangent starts at 0, goes up to pi over 2 and down to negative pi over 2. So this graph on the right is actually our exactly negative tangent. Because all we did was we just flipped it across the x-axis. This is really ugly, I'm so sorry. So this is actually just the tangent of x over here. So if we look at like, okay, so tangent of x, but I made it negative, so that gives it that decreasing shape. So I want to do the same thing, but I want to shift it to the right by pi over 2. Or I can shift it to the left by pi over 2. So because they have that nice period of pi structure, it actually doesn't matter which way we go. So I'm going to take my tangent and I'm going to shift it by pi over 2, and I'm going to flip it across the x-axis. So I took my tangent and moved it over, boop. So it looks like this now. Yeah. And then I made it negative so that it flipped it across to get that nice cotangent-y looking shape. Beautiful. Okay, so those are our two equations using tangent and cotangent. So you can basically get around between the function and the reciprocal function of tangent, so tangent and cotangent, by using translations. So you can get that nice phase shift because they're pi over 2 out of phase, and that negative sign in order to flip it across the x-axis. And that's it. So to sum up, whenever you plot these weird reciprocal functions with a bunch of shifts and things, start by plotting the original trig function. So if you have a secant, start by plotting the cosine with all of the same shifts. And then go figure out, okay, where does it cross the symmetry axis? There's my asymptotes, bam. Where's my maxes and mins? Okay, that's where my U-boats start. And call it a day. Hope that helped. Let me know if you have questions. Ciao.